How's it going, Jabroskis? Welcome back to Mars. So, yeah, man, I tell you what, every time I play Stationeers, it impresses me more and more. Today, I want to focus more on the chemistry aspect of the game. Uh, Even though I taught Chem Lab, I am not a fan of chemistry at all, especially when you start getting into equations. Of course, chemistry is cool because you get to blow shit up, and and chemistry is responsible for rockets getting to space. But as far as the memorizing of the periodic table and learning the atomic mass of certain elements, and especially the equations, no spank you, don't sign me up for that nonsense. However, like everything else scientific, this game handles chemistry like a boss. Of course, it's not like, at least not in this at this point in the game, it's not like Breaking Bad kind of chemistry, but it is the rudimentary chemistry that it has to offer you early in the game is presented in a fun way. And I wish I would have had this game when I was in junior high and high school. Maybe I would have paid attention to in chemistry more. So as you can tell, I'm at the point where I got my base all skinned and sealed up nice and tight. Now it's time to pressurize it and fill it with that sweet old air. Now to do this, I'm going to walk you through some of the basics of what it's going to take. And I'm going to try to take it a little slow so I don't miss anything, because this game can be complicated. And I just realized I forgot to reinstall a panel on this wall. I'll have to do that later because I don't have any on me. Okay. So here's the problem. Here are the issues. I'm going to lay them out for you. Mars, if I bring up my wrong button. If I bring up my tablet here, turn it on. The Martian atmosphere, just like in real life, is primarily CO2, carbon dioxide. But we also have some oxygen, barely any at all, and a little bit more than that, zero point 0.3 moles of nitrogen. Okay, and the X is just like poisonous random gases, I guess. We'll pay no mind to them. So the question becomes, how do we get breathable air inside of our base when this is what we have to work with? And just like on real Mars, there is frozen oxygen and hydrogen and water underneath the surface. Okay, you can kind of see in the background there. Right there's a blue stone-ish looking thing. I think that might be silicone, but there's other minerals out there in the Martian dirt you can dig up. I've already done that. Okay, so let me bring up my belt here. This is oxide. If I take it out of my mining belt, it'll melt because right now it is 11 degrees Celsius, okay? And 0 degrees Celsius is freezing, so I don't want these to melt. But oxide, if we bring up our Stationpedia and type in oxide, it tells us everything we really need to know about it. Oxide is made up of oxygen and nitrogen. Each oxide ore has 22.5 moles, and that's just the standard, the SI unit for gases here, moles, and nitrogen 2.5 moles. So a lot more oxygen in each oxide ore than nitrogen. Okay, if we go to ice, like water ice, we get a little bit more nitrogen and obviously oxygen and hydrogen, but you'll have to separate those using an advanced machine that I don't have and I don't plan on using. But you get about twice as much nitrogen with each ore of ice water over oxide. So this is where we can get our oxygen. But here's the thing. If I take you over here, let me turn my light on. If I take you over here to my greenhouse, if you watched my previous videos, you saw that I had this thing pressurized, but you may not have noticed that what it was pressurized with was mostly oxygen, about 90% oxygen. Now, I didn't think about it too much because, I just took these oxide ores and I just dumped them in there and let them melt, and I let the melted oxide fill up the atmosphere inside the greenhouse with 90% oxygen. Thankfully, not thinking it through, but thankfully, I didn't light my welding torch in there or anything, because as NASA learned during the Apollo 1 testing, it doesn't work out so well, okay, in a mostly oxygenated environment. So we can, but I don't really want to just let these things melt inside the rest of my base now that it's all connected and it's all just one big atmosphere. because that's one big bomb. That's going to be one big fireball if I accidentally light a match or create too much friction somehow. Or maybe one of my wires sparks like underneath John Grissom's seat in the Apollo 1 capsule, and then all of a sudden I'm toast. So the problem is, the solution that we need to figure out is, how do we fill this Martian base with an atmosphere, with an environment that is kind of like what we have here on Earth, 20 to 30% oxygen, and then 70 to 80% nitrogen. Okay, that's what we're going to aim for. All right, so we need to find a way to basically melt these inside, but then bring the oxygen level down. So let's go inside. Now that I kind of laid out the basics, you'll see that I do have some pressure in here, but we're only about halfway there. It is breathable, but again, if I take out my analyzer, my atmosphere analyzer, you'll see we still have like 70% oxygen in here, 22% nitrogen. The carbon dioxide is a little high, but I'm happy with that. But I need to reverse these basically. I just need to flip-flop these. I want 70% nitrogen and 20% oxygen, give or take. That way, we'll be safe to start a fire on accident if that's what happens. So how do we get the O2 level down, raise the nitrogen level, which is going to be the challenging part, and then increase the pressure at the same time? So I started with a different method. I'm on my second attempt now, but the first method I started with was, I was thinking, if the Martian atmosphere outside where we just were, if it has 0.3 moles of nitrogen in the air, maybe there's a way we can suck that out of the Martian air, bottle it up, bring it inside the base, and then let out that nitrogen gas and fill our base up with nitrogen gas. So that's what I tried to do. So let me take you down to our pump room where I was doing that. Okay. Now this is a different setup now because I'm on my second attempt at a different strategy. But basically what happened was, no matter how many intake vents I set up, no matter how long I let the filter run, it just is going to take too long to bottle up the nitrogen. I probably ran the thing for 2 hours straight, and I probably only filled up this bottle right here about to that line, if that. Okay, probably not even that. So that way was out. So now I'm on my second idea. Okay, and I'm sure there's better ideas. I didn't want to look online to see what other people were doing. I want to try to figure this out on my own. I'm sure there's more technology I can unlock later that will help out with this, but right now this is what I got to work with. So this is the plan now. Okay. My plan is, and this is what I've done a couple times and it seems to be working, but I'll show you. We take the oxide, which again is mostly oxygen. We let it melt in here. These are the intake vents that suck in all the gases that are in here. All the carbon dioxide, all the oxygen, all the nitrogen, everything goes in here. This turbo pump pumps it into our filter, where I have these oxygen filters that basically siphon off the oxygen. The oxygen runs through this tank and fills up these bottles. So basically I'm bottling up the oxygen now instead of the nitrogen because there's more of it to bottle up. It should be faster, is my train of thought. Meanwhile, the other gases that aren't oxygen, that are sucked out of the air, just get recycled back into the air through this outtake vent. Okay, and the process just keeps continuing. So with each dump of these groups of oxide, I'm putting a lot of oxygen into the atmosphere in here, as well as at least some nitrogen, and I'm just bottling up the oxygen, and that should reduce our oxygen levels while increasing our nitrogen levels. So let's demonstrate this and see how this works. Okay, I'll keep this up and running. It is 14 degrees Celsius in here, so these should melt. Let me go ahead and turn on our pump. Now I got to be careful because this pipe right here between the filter and the pump will start to get extremely pressurized because the filter just can't keep up with the amount that the pump's pushing through it. I can turn the pump down, but I rather just turn the pump off when I hear this thing starting to whine and creak, and then just let this filter run for a little bit longer to drain that pipe out. And I also need to keep an eye on my oxygen tanks over here because they're almost filled up. 10 megapascals is the limit on those before they cave, or should I say concave? No, it'd be, you have concave and convex or something. I can't remember. It's getting pretty late. I should probably call it a night before I blow myself up in this game. So let's go ahead and do this thing. We'll turn this on first, and we'll turn on our pump. Oh, that's the on button. Put the oxide in our hands, and look at it melt. Oxygen should go up, and so should our nitrogen. Both are rising. Oxygen obviously a lot faster than nitrogen, as expected. We've got about 15 oxide left. And once that oxide is gone, it's completely melted out of my hand, then the oxygen should start going down. But then the nitrogen should keep going up. So we'll just dump some more oxide into the room. Wait for it to disappear. All right. Oxygen levels should start to go down. There they go. Nitrogen should stay about the same. This is getting a lot of pressure on it. We should probably back it off. Okay. 43 megapascals is quite a bit, so we were going to back that off there. Let the filter empty out that little pipe. All right, we're getting there. Nitrogen just overtook oxygen. Nitrogen is now our most prevalent gas inside of our base. I did a few little upgrades, added a few more vents, made this intake pipe a little bit longer, just so it could store more gas in there. How we looking on this? Ooh, about to shut it down. Again, 10 megapascals is the max pressure on these oxygen tanks, so I'll have to set them over there. I might even empty them out in the Martian atmosphere, just so I can reuse them. All right, been at this for a little while now, and everything's looking pretty good, looking nominal. I've been loading a bunch of oxide in the room just now. That's why our O2 is above our nitrogen, but once everything stabilizes, our nitrogen is well above our oxygen. We're getting close. These tanks are also getting close to capacity. So in a second here, I'm going to show you a new change I made. I did have like 10 of these yellow oxygen tanks lying around over there. I was like, this is ridiculous. I don't want to waste that oxygen and release it back in the atmosphere. Definitely don't want to release it in here, or why am I doing this? I figured, I got to build a rocket eventually to get off this planet, so I'll probably have to use LOX. So I might want to store this oxygen in a more practical way. So in a second here, I'll show you what I've been doing. All right, our tanks are just about full. So we're going to shut this down. Take these up and out. This always reminds me of the movie The Martian, when he keeps having to go in and out, using the airlock until he breaks it. Hopefully I don't do that in this game. That would be bad if this all depressurized. All this work for nothing. This thing. This is just my emergency hatch in case I lock myself out of my base. Something I definitely don't want to use, but if I have to depressurize this base in order to get back in it, then so be it. I'd rather have to do that than not be able to get in at all. this right here. So here's the large oxygen tank I built for storage. Thing's the size of a Starship methane tank. Am I right? Let's see, this needs to go this way. Turn that on. And this pressure should drop. And she's dropping. Meanwhile, this pressure should rise. Definitely loving this game. It is so much fun to be challenged in this way. I think when the time comes in the distant future, I'll probably put the rocket about right over here. This looks like a nice, decent area for it. Probably have to put a large methane tank right here. I'm guessing methane's the fuel I'm going to have to use. Alright, let's take this stuff back inside. Okay, so this is just about where we want to be at as far as the atmospheric makeup of our base. We just need to raise the pressure a little bit. Right now the pressure is dropping because all the air in here is moving itself throughout the base. You can see the little lines moving, the wind moving through the through the base. So we just need to add maybe a couple belts full more of the oxide, and we should be just about all set. All right, I think we are finally good. Let's check it out. 70% nitrogen, 25% oxygen, a little bit of carbon dioxide as well, but we're gonna need that. Check this out. Oh yeah, breathe that sweet manufactured air. All right. All right, here we go. This is the true test to see if I really know what I'm doing. Will I blow myself up? Hey, look at that. I'm alive. Yeah, we're going to need that carbon dioxide because the next thing on my list is to plant some crops up here in the greenhouse. All right, and maybe we'll go over all that stuff in another video because we can also do some cooking. Yay, culinary. Until next time, Godspeed.